Hello guys, welcome to the GMAT section on data sufficiency. It's a part of the data insights as you already know. So there have been recently a lot of changes going on in the data sufficiency type of questions. So earlier, as it used to be, like there used to be a lot of quant-based questions, right? Like which are based on the quant topics that you are doing in problem solving. Because that at that point it was a part of the quant section. Now that data sufficiency is now a part of data insights, which is a separate section, the questions have now been changed a bit. So though there could be quant-based questions, but those would be not something which would have a lot of computation involved. Typically, questions on inequalities or maybe number properties with core solving techniques in data sufficiency would most likely not be seen further. Okay, so questions will be more likely on maybe basic arithmetic, where you might have to deal with very basic level functions. I mean, percentages, sorry, very basic level percentages or ratios might be there. But a major chunk of questions would now also be from verbal reasoning, like which we also sometimes call it as logical reasoning. So we reason out using basic logic. So to help in that process, we'll basically have a look at some conditional statements. So a lot of those questions will come to I mean, there are two parts to this video. So first part, we'll look at the basic ideas behind it, and then we'll take a look at like around five questions, which are based on the new data sufficiency format. So a lot of these questions are based on reasoning. So conditional statements, you will see questions like if, then, or unless, then. So how do you interpret such statements? So there is a small, I mean, nice and easy technique which we can use. We do require a little bit of rote learning for that, but then that really helps you in the process. Okay, so we'll just quickly go through that part. So first, let's look at conditional statements in data sufficiency. Okay, so conditional statements look typically like this, like if P then Q, then only if P then Q, unless and either or. So what are these basically? If P then Q stuff. So let's take a statement. So if it rains, that it rains is the P part, okay? Then I wear a raincoat, let us say, is your Q. So if it rains, then I wear a raincoat. So what can we conclude from this? Okay, so P is true will imply Q is true, meaning it is raining. So what I'm saying is, okay, if it rains, then I should wear a raincoat, right? So if it is raining, if let's say that is a true statement, then it implies that I am wearing a raincoat. But if also means that if Q were false, then that means I am not wearing a raincoat. What does that imply? Then P must have been false as well. That means it must not have been raining. So this is the statement as it is. This is called its contrapositive. Okay. So what is contrapositive? We are basically saying the same thing in a different way. Okay. We are saying the same thing. So this and this are not two different statements, but they are mean the same thing. Their essence is the same. Their ideas are the same. It's just a different way of writing it. Okay. It's just a different way of writing it. So it's something like, I mean, changing the wordings kind of. Okay. So Q is false means I am not wearing a raincoat, implies that it is not raining. So whenever you see a statement which talks about if then, you not only should think of that P true, Q true case, you should also start thinking of what if Q false, P false case. Okay. And these are the things which are going to help you in your data sufficiency state analysis of the statements that are given. Okay. Next, here we cannot say anything if P were false. P is false, then what? Nothing. Okay. So it is not raining. I can still wear a raincoat, right? Just in anticipation that it might rain, or just to have fun, or maybe I want to play in the mud, whatever. Okay, so there could be like hundreds of reasons why I decide to wear a raincoat. I might be mad that I'm wearing a raincoat, but can't say anything. And in the same way, if Q is true, that means why am I wearing a raincoat? I mean, if I'm wearing a raincoat, does not mean that it is going to rain. I mean, or it is raining. I can't say anything again. Another way of looking at this statement is, let's take something which is easier to understand. So if a tiger chases me, that's your P, then I will run is Q. Now this will be very easy to understand. So if I say that the tiger is not chasing me, so if the tiger is not chasing me, does it mean that I will not run? I can still run because I have a bus to catch, I have a train to catch, whatever. Okay. Similarly, if Q were true that I am running, does it mean that I always have a tiger running behind me? That's why I'm running. So it obviously is not true, right? So I am running because of hundreds of other reasons. So that means if I'm looking at an if then statement, P is true. That means if a tiger is chasing, I'm definitely running. Okay. Second, I am not running. Whatever be the case, at least the tiger isn't chasing because if it were, then I would be running. So these two are fine. But if P is false and I start saying that, okay, P is false, the tiger is not chasing me, conclusion is I am not going to run. That is a wrong conclusion. Similarly, I am running. That means a tiger must have been chasing me. That is also a wrong conclusion. So this is the main statement. This is called its contrapositive. Contrapositive. And these two are the converse and the inverse. Okay. Converse and the inverse are wrong logic. So they're wrong. Okay. They are not to be used. So when you are analyzing a statement, you should not use the logic that P is false implies Q is false, etc. etc. Okay. P is false means nothing. Q is true means nothing. So this is the analysis of an if-then statement. Let's look at this, what I was talking about. So the converse of the converse of the statement, if P then Q. That means if Q then P. So if P then Q is the statement, the converse means you reverse the logic. Okay. So if Q then P, which is false, wrong. The contrapositive is if not Q, then not P. And this is correct. This means the same as this. Okay. If not P, then not Q is basically the contrapositive of this. See, if Q, then P. If not P, then not Q. It's the contrapositive of this. Since this itself is false, so this itself is false. Okay. So if a positive statement, if P, then Q, how do you make its contrapositive? It's very easy. Reverse the positions of Q and P and negate. If not Q, then not P. Simple. So if this is true, then this is also, when this is a correct statement, then this will be a correct statement as well. Okay. That's how you make the contrapositive. Let's get back to the other types of statements that we were looking at. Next one is only if P, then Q. So only if P. So it's kind of the only necessity is this. So this was a sufficient statement. This is a necessary condition kind of. So only if P then Q, say for example, only if a tiger chases me, then I will run. So that means I will not run under any circumstance other than that a tiger chases me. So the statements could be I am running implies the tiger is chasing. That's what it means. Okay. Contrapositive, a tiger is not chasing me. I will not run because that's how I've made the statement. That the only scenario where I will run is if a tiger chases me. Under no other case would I be running. So if I am never running other than that, and I'm saying that the tiger is not chasing, therefore I'm not running. So this is the statement, this is its contrapositive. Okay. Unless P, then Q. So unless, say, let us take unless the tea is hot, then I will not drink it. So that's your P, that's your Q. Unless the tea is hot, I will not drink it. So if the tea is not hot, that means P is false. Whatever be the tea from, wherever be it from, I am not going to drink it. So Q is true. Note that Q itself is negated. Okay, I will not drink. That's how the sentence syntax is, construction is for unless then. So here Q is true. Okay, the tea is not hot, I will not drink. So I will not drink is Q. So Q is true. Similarly, Q is false. Let us say Q is false means what? I will not drink is false means I am drinking the tea. And I had said that unless the tea is hot, I'm not going to drink it. But you find me, I'm drinking. That means what? The tea must have been hot. So P must have been true. So P false, Q true, Q false, P true. The statement and its contrapositive. The last one, either P or Q. So either A will bring the book or B will bring the book. So this is your P, that's your Q. One of them has to bring the book. That is the condition. Either P or Q means at least one. At least one of them has to work out, has to be true. So if P is true, Q may be true, may be false. We can't say. But if P is false, that means Q has to be true. And similarly, if Q were false, P has to be true. So that's the condition. Okay. Both are true is not a problem. In certain cases, it might be that both are true is not physically possible. For example, either I laugh or I cry. I can't be doing both unless I want to make myself look silly. So other than such cases, both of them might be happening, but neither of them happening is not possible. Okay, that's what either or stands for. So to summarize, if P then Q, P true implies Q true, Q false implies P false. Here Q true implies P true, and P false implies Q false. Here P false implies Q true, and Q false implies P true. The same thing here as well. P false implies Q true. Q false implies P true. Okay, so you can keep the four things in mind and with that analyze the statements. Okay, keep up making up the conditions, the main statement and the contrapositive whenever you come across any of these, and then analyze the whole picture rather than just thinking of the main statement. All right, I hope this is clear. Let us now look at a few of the exercises, questions, which are actually official questions. So this is the first one. Okay, so let's read this. So it says that four book lovers have recently met and are not sure of the topics that interest the others. The table indicates the topics that interest each of them with tick marks and those who do not with cross marks. Now, one of these persons will gift another of these persons two books, each on a different one of the listed topics. Will at least one of the two books fall under recipient's broad topic of interest? So one of them is going to buy two books for another guy, another person. We have to check whether at least one of the books satisfy the interest. At least one. So even if you get one, it will be fine. Okay, you don't have to necessarily get all two books satisfying the condition. That's the main takeaway from this. So as you can see, this is more of a tabular data where you have to just check ticks and crosses. Okay. Now, first statement, let's look at the first statement. It says one topic is science fiction, the other is humor. Now, if you look at the column, the row for science fiction, you see that A, C, and D like science fiction. There is only one person who does not. While if you look at humor, A, C do not like it, but that's not important. What is important is the guy who did not like science fiction actually likes humor. Now, Deepa or D likes both, so that's fine, not a problem. Okay, so now, irrespective of who is buying, okay, there's some guy X who is buying books. Let's say this guy bought these two books for Alex. Alex will like one of the books, right? Science fiction, because it has one tick. Just focus on this line and pairwise. So for Alex, you have one tick, satisfies. For B, you have one tick, satisfies. The main point of contention was that B did not like science fiction, but then it's made up using humor. So if instead of humor, the other book was history, then there is a problem because B will not like. But here it is humor and B has a tick. So one of them is a tick. So that's fine. C likes one of them. D likes both of them. So irrespective of for whoever the book is for, definitely yes. And since we already analyzed that irrespective of for who the book is for, at least one of them is going to, and at least one of the books will be liked, okay, by those people. So it will be true for C as well. C also likes one of the books. So the answer is clearly D. So you see that it is very different from what we were used to doing, like a lot of quant and numbers and juggling and all that. Not much of numbers here, pure logic. And we are actually not even using conditional statements here. We are just looking at ticks and crosses. Where does it satisfy? Okay. Let's go to the next one. So this is comparison. So it says there are 5 coffee and chicory blends. The point to be noted that these are the two things that are being blended. Okay. So if you don't understand what chicory is, it's just something. Okay. It's just something which is mixed with coffee. Okay. Now there are 5 brands, JKLMN. All are priced differently. The blends are such that the higher the coffee, the higher the price. So coffee content up implies price goes up. At the same time, the greater the chicory, the stronger the flavor. So if chicory goes up, the strong flavor goes up. Okay, that's what is given. If the 5 blends were ranked in order of cost, so if you are arranging in terms of cost, you are as good as arranging in terms of coffee content. That is now what is important. Cost basically means coffee content. So these things you have to analyze, okay? You have to observe. Now, first statement says blend L has higher coffee than all the other blends except M. That means if you were to rank from high to low in terms of coffee content or hence in terms of cost, because they are actually the same thing, coffee and cost. So then L would be higher than everyone else except M, means M is on top, L is below, and you have 3 more brands after that. Okay. M and L are on top. The 3 more could be J, K, N. So J or K or N in any order. We don't know what that order is. So that's what we know. Is that enough to answer who is in the middle? No, we don't know the middle value, right? Because we need the median value here in terms of cost. This is given in terms of coffee, which is basically translates to the order of cost. So we don't know the middle one. So 1 is not sufficient. So statement 1. Let's look at statement 2. Ignoring statement 1. K and N have stronger flavor. So they are stronger than J. So that means if you look at strength of the flavor, K and N in any order would be above J. Strength means chicory, right? Same thing. But then we don't really need chicory. We don't really need strength. We need the cost. Okay, that is what is important. So if chicory is in this order, that means you are saying K and N have very high chicory compared to J. That means the percentage or proportion of coffee in K and N must be lower because it's just a mix of coffee and chicory, right? So if K and N, let's say, have 70% chicory and 50% for J, that means coffee wise, J has 50% coffee and KN have only 30% coffee. So the percentage for coffee would get reversed. So from here, I can conclude according to coffee on and hence therefore cost, J will be on top, K and N will be below. But then again, we don't know whether K is the second and N is third, or N is second, K is third, or is there someone else above J in the first place? That also is not known. It's not given that J is the highest. Okay. So statement 2 does not work out. Now let's merge them. So we'll try to arrange in terms of coffee content or cost. Statement 1 is already on the basis of coffee content or cost. We'll just continue building on statement 1. We already have placed ML. So now you have to place K, N, and J. Okay. K, N, and J in terms of coffee or cost is J, then followed by K, N. Obviously, the first two slots are gone and you need to have three things below it. So obviously, J has to fill up the third place. K or N, N or K can come after that. So who is in the middle? J. By combining, we have the answer. So we have our answer as C. Okay. So we saw two questions. One, this one, which was answer was D, either statement alone. This one we now have combining both, we have our answer. Next. Some information text form is given. Last summer, as with every summer, Roshin and Reena, let's say O and R, have made a trip together to a town neither of them had ever visited before. Okay. So the point here is neither have visited before. So that means the town should be such, the town was such that neither of them had been to that town before last summer. Okay. That's what it is saying. For the long summer trips, O and R have always chosen to visit a town that R prefers. So obviously, between the judgment or calls taken by O and R is the one who decides, not O. Okay. So next, this is what this here, this stays true unless O has already visited the town. So if O has visited the town, then they don't go to that. So it's kind of a part of this only. So there are basically two conditions. R decides, and at the same time, neither visited before. So if R has visited before, then also they will not go. Then obviously R will not decide. That makes sense. If you have already visited before, why will you decide that city or that town? And the other case is O also. So neither have visited before. That means if R has decided and O has already visited before, then it will be dropped. So there are two conditions. Who decides? R decides. What's the other condition? Neither has to be. Neither must have been to that town before. Let's analyze the statements. So it's saying that R had visited town F and G. So we are looking at two towns, F and G. And then Ocean had never visited town J or K. So basically there are four towns, F, G, J, K. The question is, did they visit one of these four towns? So we are just focusing on these four towns. Okay. Can you answer the question uniquely or not answer the question uniquely? Okay. That's the state. That's the question. It says that Reena visited town F and G before. So that's straight away out, because we already know that neither has visited before. So if Reena has already visited F and G before, then definitely they did not visit F and G again. So we can just ignore FG. We can just focus on JK. Now we know that O has not visited J or K. Fine. O has not visited. But then we don't know whether R has visited J or K. So we neither can accept nor can reject just on the basis of whatever is given in the statement stem. So we have J and K with us. Now let us look at the statements. So the first statement says R has never visited J. So R has not visited J. So that is a probable city which can be considered. But we don't know whether O has visited J. But we already know that O has not visited J, right? So O not visited, O not visited. So there is no, let's say, opposition to the selection of city or the town from O's side. So O is out of the picture, kind of. Okay. So O is nothing to decide. O has not visited J and K. O is okay to go to both of them. Depends on whether R decides or not. First statement has said that R never visited J. So if R decides, then they will go. If R does not, then they will not. But just because R has not visited J does not mean that she will decide. Okay. So here in that conditional statement comes in. Okay. They will choose a city that R would have liked to visit. So that means if R likes, then visit. It does not mean that if J has not been visited by R, then R will decide to go to J, right? So if R likes, then visit. Another one is if not visited, only if not visited, then visit. Okay. So the two statements, if based on the conditional statements we had discussed, if R likes, then they will visit. Only if this was not visited, then they will visit. This means they will visit only if they had not visited. It does not mean that J was not visited, therefore they have decided to go to J. We can't say that. For only if, remember, the condition was only if P then Q means if Q is true, then P is true. Okay. And if P is false, then Q is false. That means if they had not visited is false, means if they had visited, then they will not visit. That's true. And if Q is true, means if they visit eventually, then it implies that they had not visited earlier. That's also true. But if they had not visited, means if P is true, then what? Nothing. We can't conclude anything on that basis. Okay. So statement one, R had not visited town J does not lead to any conclusion. O has not visited town F is irrelevant because F and G are anyways out of contention. So this is irrelevant information. Let's look at statement two. O would have liked to visit G or K. Now, whether O likes to visit G or K or not like to visit G or K is irrelevant because O's decision-making capacity is not there. Whoever decides is basically R. The only condition was O should not have visited those two cities. We already know that O has not visited K, O has not visited J. G is anyways out of contention because we already eliminated. O not liking or not liking K has no role to play in this decision. So from 2 is basically a completely irrelevant information because decision making is with R. R decides. So even if I try to combine now, since statement 1 was not sufficient and statement 2 is irrelevant, even then you cannot answer the question. So the answer is E. So here, see, we have an example where we use the conditional statement only if then, as well as if then. There were two statements. If R likes, then they visit, and only if not visited, then they visit. So this was the catch. So if you had decided on that basis that J was never visited by J R, therefore they will visit, that would be wrong. Okay. So I'm just repeating that part again. R had never visited J. The statement was only if not visited, then they will visit. That means if this is not visited is P and visit this year or last year is Q, not visited earlier the is P, then Q true means they visited last year would have implied that they had not visited earlier. And P is false. That means if they had visited before, it would imply that then last year they visited is false. That means they will not visit. But if P is true, that means they had not visited before is true, it does not lead to any conclusion whether they are going to visit last year or not. So that was the catch in this question. It stands as option E. Let's go to the next one. Let us look at the next question that we have here. So this one says that there are 20 different subjects in a library, including history. A librarian picks up 100 books for reshelving amongst the books returned that day. Uh, all the books returned that day were borrowed during the past 3 weeks. Are fewer than 20% of the books the librarian picks up on history. So they're saying, do you have out of these 100 less than 20 books picked up? So out of 100 books, less than 20 on history. Are less than 20 on history. So statement 1 says less than 20% of the books are on history. So this is talking about the entire set of books in the library, and is saying that fewer than 20% are on history. So it might be that the library has 1,000 books, and on history there are like fewer than 200 books. But it is also possible that the books that were picked up, those 100 books for reshelving, all of them were on history. So then the question, are fewer than 20% of the books the librarian picks up on history? The answer is no. But it is also possible that in the last 3 weeks rather, only one book was ever borrowed, right? I mean, on history. So out of the 100 books, there is only one such book on history. So that means how many books are in the library as a whole has nothing to do with how many books on history are there in those 100, right? So this has no connection to what the question is saying. This is an irrelevant statement. So if this is irrelevant, then even combining would not have actually helped. So if 2 is fails, so option statement 2 fails to answer the question, then the answer is going to be E. Now, if you look at statement 2, it says only 15 books were borrowed. Now, if you are borrowing only 15 books, then the maximum number of books that could be in those 100 books is 15. Right? Because during the past 3 weeks, you borrowed only 15 books. You are picking 100 books from the last 3 weeks only. So that could never have more than 15 books on history. And if that is true, then the maximum percentage would be 20%. Less than 20% for sure. So statement 2 is clearly sufficient. The answer is B. So here you see there are a bit of numbers present, but then very basic level number calculation. There was no calculation at all in the first place. Very basic level understanding of percentages and samples is what is required. Let's look at the next one. So it talks about a couple that decide one day they will definitely go to the beach the next evening. They will go to the beach the next evening if it is sunny without rain at the time they plan to go. So that means if sunny when they plan, then we'll go. Okay. If P, then Q. They will definitely not go if such is not the case. Means if not sunny when they plan, then will not go is also given. So we have learned that in P then Q, P implies Q, P true means Q true, and Q false means P false. That's what we know. Here, given that P is when if sunny when they plan, they have also stated that if P is false, then Q is false. That means let's put it as a different. No, let's not take P and Q, otherwise it will be very confusing. Let's take R and S. So if R is true, then S is true, which R is true means not sunny, means what? P is false. S is true means will not go, which is negation of Q. So that means inverse of Q. That means Q is false. So this is given. And hence the reverse, S false, then R false means Q true, then P true is also known. So that means we have from here, if I assume that P is sunny when they plan and Q is will go, what we have been given is P is true, then Q is true, Q is false, then P is false, P is false, then Q is false, and Q is true, then P is true. We know all of them. That means if it is sunny, they will go. They did not go means it was not sunny. If it is not sunny, they will not go. They went implies it was sunny. So all is known. Now let us look at statement 1. It is raining on the morning and in the afternoon of the day of their planned beach outing. So in the morning and in the afternoon, it was raining. Okay. But we don't know that it is highly possible that that it stopped raining immediately after, and then they planned, and then they went to the beach. Because we don't know what was their time when they planned. Okay. It is also possible that like at midnight kind of, okay, they decided that it was not raining, so let's go to the beach. And if they have decided they are going to the beach, right? Nothing else that happens afterwards is going to change their decision. So statement 1 is not very sure, not very clear. The simple reason is when are they going to plan? That time is not known. Statement 2 says, now there is another information given. The next morning, the hour by hour weather forecast says that in the evening, it will be sunny without rain. Okay. They hear some forecast that says that in the evening, it will be sunny and there will be no rain. Fair enough. But then nowhere has it been mentioned that they are going to decide on the basis of a weather forecast, right? It has been clearly mentioned in the first statement when we are looking at the statement 1. When we are looking at here that they decide that they will go if it was sunny at the time they planned to go. Nothing else that happens afterwards, whether there is a weather forecast or something else, or it rains incessantly, there is rain, they will not necessarily change their decision. Okay. So once we know all this, statement 1, it is raining in the morning, in the afternoon. So you can't say anything, as we said that we do not know what time they were going to plan or they have already planned. Statement 2, they believe the weather forecast is accurate. Okay, they might believe that, but then the statement here, the main stem, does not say anything about they relying on the weather forecast to decide. It was mainly that at that point when they decide it should not rain, and if they decide that it is not going to rain, they are going to visit the beach. So statement 2 is irrelevant. Statement 1 is not sufficient information. Even after combining, it's not going to give you any information. So the answer is E. So though there was conditional statements involved, we did not need to use that to that effect because the statements were majorly flawed because of inaccurate information. First statement was inaccurate in the sense that the time of their decision making was not clear. The second one gave some information which was completely out of context, which was not relevant to the main stem given here. Okay, because the weather forecast, even though it's mentioned in the stem, has no bearing on their decision making process. Their decision making process is clearly given in the first 2 lines. And hence the answer should be E. So I hope you have got some idea of what sort of questions you are going to get. To practice more, one good source could be to get into LSAT. If you look at LSAT papers, they have a lot of these sort of logical games, okay? Logic games. Though the games they have, logic games are like puzzle-based scenarios like these, but they are much more involved, like with lots of data and lots of information. But if you could practice a few, okay, puzzle-based games, logic games here from the LSAT, then you would get a better holding or better understanding of, better hold of these statements, the conditional statements that we have been talking about. Because all these games are based on these conditional statements only. Even though this will not be, I mean, the LSAT game questions, puzzle questions will not be the type of questions that you get on the GMAT because those will be much more detailed and much more elaborate. But in the GMAT data sufficiency, the questions are much more short and hardly based on one or two statements. But still, even if you try to solve, like, say, 10, 15 of those, and maybe go through the explanations if you are, let's say, not being able to solve, like, go through the explanations and how they are going to analyze and how they're solving, that would actually help you to understand more, better, these sort of data sufficiency statements. I hope this session was helpful. Thanks for watching.